This is so often overlooked where people come up with crazy, crazy things and they forget about the very basics, which is
All right, welcome to the Bioinformatics Lab podcast. I'm Kevin Libuit with Andrew Page. We're from Theogen, and today we're continuing on a conversation from the last episode regarding the 10 best practices for public health pipeline development. Let's hop right into it. Number 6, use of common file formats. Andrew, your take.
this is so often overlooked where people come up with crazy, crazy things and they forget about the very basics, which is there's a set of file formats out there for everything, and if you should probably just use one rather than reinventing the wheel. Sometimes people think, oh, I'm just outputting a little bit of data, I can make up, I don't know, a spreadsheet or tab delimited file. But actually, if they go spend a little, an extra 5 minutes, they could probably output something in a nice format that can be ingested by other programs. And that's what enables then bioinformatics pipelines to be built. And, because you don't have to then make the next thing and the next thing and the next thing. Because so much of bioinformatics is just munging data, changing from one format to another to another. Uh, and that's a lot of wasted effort. Whereas if we just take that extra step and make a standard file format, so what are your big bugbears in this, Kevin?
It's the barriers are whenever you're looking at a resource and maybe the authors fail to appreciate that it's being implemented in a whole ecosystem of analytical processes. So if it's in a non-common file format, it just inherently creates a barrier to the whole ecosystem in which it's being implemented in. Where again, you might have to munge that data just so it's compatible with whatever next downstream analytical process that's happening. So that's why we felt it very appropriate to talk about, hey, what are, or as a best practice to adhere to the common file formats. And I think already the discussion in the working group is to take this a step farther and define exactly what those common file formats are, maybe provide documentation. I know there's like whole communities around VCF header files and things like this, and all the rest, so that again the standardization, the theme of this document is standardization of these kinds of
Yeah.
resources, and of course file
Well,
formats
kind of
fall in that.
a bonus that people often overlook is that parsers for different languages can ingest these very easily as well. So it saves you work.
Mm-hmm.
Say like BioPython has a range of parsers for all the common file formats. So you should never read in a FASTA file or a FASTQ file yourself and parse it yourself and go, oh, there's 4 lines in a FASTQ file. That's easy. But actually, the spec says that they could be broken over multiple lines. It's all these edge cases that you kind of never think of. Um, so yeah, you should always use those standard libraries and standard parsers where you can. Just saves you a huge amount of effort, and you're not going to go too far wrong. And same with reading in BAM files. You don't need to go and parse the BAM specification and look at the headers and all that. You can use PySam. Um, so yeah, use the right tools for the right jobs, and definitely use a common file format if you can. Don't make up your own, unless it's in a field where something doesn't exist. So I have generated file formats before. So say for pangenomics, the output I have for Rory, there was nothing similar. I couldn't put anything on top of anything similar. Whereas in other cases, I've been able to output, say, in GFF format or something like that, and that's a standard format where people can ingest it very easily. Also, if you are outputting common file formats, you need to make sure you use the standards itself. So if you make errors and then your program becomes widely used, those errors then have to sometimes be incorporated into the downstream tools, to account for those. Like there's a famous one, Artemis. It has an error um, in how it prints out GFF files, and so there's actually code in the say the Perl GFF parser saying, oh, if this is Artemis, it's probably not going to have this line here, so just continue. It's like, oh, that's not good.
Oh man, I hate to call out a specific lab and a specific tool, but this is kind of infamous throughout the SARS-CoV-2 bioinformatics developers. IVAR outputs the variance in TSV. So there's this whole TSV to VCF file formatting like bash script
Yeah.
that goes around just so we can make sure that it's in that common file format. So it still exists. We want to put it out there as a best practice so that people can identify, hey, if you're trying to articulate types of data, there are likely going to be file formats readily available to do that in a way that the field anticipates.
One final one is that I wrote a little tool called Snip Sites. All it does is it just takes a multifaceted file and then outputs, where the snips are. But I went to great lengths to actually output VCF because that's as you say, it's a standard file format, and it does take a lot of extra effort sometimes, but it's worth it in the end.
Mm. Number 7. This one's an interesting one. A lot of conversation back and forth in our sub working group, but we really do feel as if it's a best practice that is emerging. But we kind of want to plant our flag in across this line in implementation of software testing. Not traditionally done. You see all different types of ways in which people approach this, but if it's going to be implemented in a public health lab where public health decisions are being made, we feel it's a best practice to ensure there's some level of, at minimum, manual testing articulated out, but at best really automated testing. So when you incorporate changes, you are ensuring functionality throughout versions. Thoughts on that, Andrew?
Yeah, I mean, I'm a software engineer originally, and so testing is very close to my heart. In all the tools that I've been developing over the past few years, I always put in a tool suite or testing suite um, as an absolute minimum. Because if you make a change, you want to know, have you broken something? And I break stuff all the time. And sometimes it's, you can spot it straight away, sometimes it's very subtle. And that's where testing comes in. The kind of the very baseline you need is unit testing. Just if I know, you put a number in, the right number comes out. And then, testing boundaries and stuff like that. Actually, what I find is I do often do test driven development. So that is you build a test, it breaks, and then you write the code to make that test pass. And it's kind of a neat way to do it. It's a whole philosophy around it. But that actually allows you to design your code as you go along, so you get a better architected system at the end because you're thinking about how should you structure these things, which files should you put stuff in, what should you call your methods, should I do it this way, should I get this output? And it's only when you start doing that, it takes a little bit longer initially, but actually I think it overall gives higher quality software and speeds everything up. So I'm a big fan of testing, full stop. But then you also have the higher level testing, as you alluded to.
Yeah, and on testing too, I think we saw a huge surge in uptake and adoption of this. I think it was a micro bin fee like hackathon or something of the sort. I remember watching Lee and a couple others walk through use of GitHub Actions. It was like, oh man, automated testing's all that much more accessible because of resources like this. Were you involved in that at all? I almost positive it was Lee and likely Robert in there as well. Okay,
It's a blur because we've had these conversations so many times. I think at
yeah.
hackathons.
I'll have to find that as a resource and maybe throw that into the show notes. But there's a great walkthrough of how to implement testing, how to use some of the free resources on GitHub, so you can start implementing automated testing.
And I
But
guess
yeah,
that's kind of going back to your Docker containers and stuff like that. It feeds back in. It kind of closes the loop because
yeah,
often when you run these tests in continuous integration, it builds a Docker container. It runs the test through the actual software in the environment that you intended it to have, and then it passed or failed. So you're testing everything at the same time. Can you build your software? Does it work as intended? Or, are there any dependencies broken? Even just getting the help message up, as an absolute minimum, and running that is actually quite a useful test.
yeah.
And there's a lot more to it, but that as a minimum, is actually going to save you know, many headaches.
And number 8 on the best practices is somewhat related to that, but having some accessibility to benchmark or validation data sets so that people who are using it can ensure functionality on their end as well. Again, a best practice we feel should just be highlighted so people know that when they're using your software, they have something to compare it to ensure that, oh, this is running in the way that I think it should be running.
Absolutely. And also the number of times that I have gone and run a piece or tried to run a piece of software and I don't know what the input file is or don't have the input file available is is annoying. And so it's actually quite good to have these small little toy data sets available so that you can just put it in and see, you know, how does the software work? What are the outputs? How does it actually feel? And it's something people overlook because often, you're working on something, you might describe it in a paper, or you might describe how to generate the data but not provide it. And it just creates a barrier you don't need. So do provide a small test data set or at least link to how it can be generated very easily.
Absolutely. Number nine, reference data requirements. I think this is a huge thing, especially with pipelines that are ever more dependent on curated databases. I think about even things like AMR Finder Plus whenever you're doing characterization and identifying these AMR elements. We use something like Gambit where you're doing taxon identification, where it's dependent on a curated database of well characterized genomes and their associated species designations. So ensuring that that is in some way documented and that those reference databases are also available to the end users in some form.
I think this is where you need to hire bioinformaticians, because and people with domain expertise, because this can be a minefield. You have to know the limits of what you're doing. You not just, you can document all you want, but there will be a lot of implied knowledge in there. Say what is a species? Like someone will say, oh well, all species are the same. Whereas, you and I will know, okay, say TB, is very tightly defined, whereas, something like I don't know, E. coli is very loosey goosey. And those are kind of things you need to know. And it is very important when you're doing analysis and doing workflows and whatever to have those things baked in. Um, and you can document it all you want, but there's a limit to what you can put in. You can't say, okay, you need a master's in bioinformatics just to be able to run this pipeline. And it doesn't work like that. So you need the highlights in there, definitely.
Yeah,
Yeah.
absolutely. Highlighting the databases that are required or that your pipeline is dependent on, the versions that are being used whenever you're talking about its availability and when it's been tested, all of those being just really requirements now and being able to communicate how laboratories can implement the workflow that you've put out to the world there. All right, number 10. It's a big one. It's an encompassing one, but we had to put it in there in some form or fashion, but strong documentation. And in the way we broke this up is documentation practices. So maybe we can kind of fire through these because some of them are pretty, again, super uncontroversial, but you need to have pipeline documentation that is clearly written and publicly accessible that articulates a number of different points. The first of which, again, we'll kind of run through. You need some kind of communication in terms of who contributed to the software, the authorship, and some kind of point of contact as well. If it's going to be implemented in a public health setting, any conflict of interest, making sure that's clearly stated. This is an interesting one. Curious to get your thoughts on this. This was again hotly debated in the sub working group, but if you see 10C, pipeline maintenance statement, is there any sort of communication from the authors regarding the intent to maintain? And that could be by a number of different ways. It could be, hey, this was written with the intent for us as a laboratory to maintain this long term, or even as far as, hey, this was written in a standard workflow language that we intend this to be community maintained and something that our lab alone or our postdocs alone can't sustain moving forward. Curious your thoughts on pipeline maintenance statement.
God, I'll have to be very diplomatic here. But I've written a lot of software for a lot of years, and I still get emails from stuff I did multiple employments ago. I'm not paid to maintain that software, so unfortunately, it has to be community maintained. No matter what you say, people still come back to you and expect you to fix something that it's usually a bug in their end, or they put in the wrong data or whatever. And so that is a little bit of a bone of contention. And occasionally I'll say to people, okay, well, if you'd like me to do this, I can see it's important. You're going to have to essentially pay for that privilege of my time. And then it's usually crickets because people have just moved on, or they figured it out themselves and they didn't really need to contact me at all. But yeah, that is a hard thing, and particularly hard because a lot of the funding, academic funding, for bioinformatics is short-lived. It's very short-lived. It's a year or 3 years. It's rarely, longer than that. It's quite rare to have projects longer than that. And then often, if they want to get more funding, they have to kind of focus on what's new and shiny rather than just maintaining. This is where NCBI and ABI come into their own, where they have, I guess, longer term funding to support things for, decades. And you can see, say, with the EMBL format and the GenBank formats, those are old school things, but they've maintained the systems for, decades to enable bioinformatics to continue. Um, so yeah, it's good, but bad at the same time.
Yeah.
So don't assume that something on GitHub means there's free support for life forever.
That's why we thought it'd be a best practice to at least communicate what the intent of maintainability is, even if it's in the case of like, hey, I personally won't have the ability to sustain this full time for the future, but at least there's some kind of statement indicating the level of maintainability from there. Um, yeah, and then moving on through the other documentation practices, community guidelines for contribution and support. That's relatively standard. Um,
Oh, what? Actually, can I
Go on,
make a suggestion there, Kevin?
please.
Since the next few topics are huge, maybe we should have a separate episode just discussing those because, you know, obviously community contributions is a big
Yeah,
thing, and I'd like to have more time to discuss it.
fair. All right, we'll close it now and then have part three on these best practices for pipelines in public health.